Today, I'd like to introduce you a paper from the magazine Mutilmodal Transportation. It's called Road Condition Monitoring Using Unsupervised Learning-Based Bus Trajectory Processing, whose author is Pruthvish Rajput, Manish Chaturvedi, Vivek Patel. I hope you can learn something. The road infrastructure maintenance is crucial for hassle-free transportation. The proposed work leverages the dense connectivity of public transportation buses for road condition monitoring at a large scale. It uses the buses equipped with GPS and accelerometer as mobile sensors to infer the road surface roughness and the damaged road segments. The vibration features are computed from accelerometer data using the in-bus controller, and trip records are processed offline using a centralized server. The proposal applies the unsupervised learning-based self-organizing map and k-means clustering algorithms on the GPS location records and vibration features to infer the road condition. The damaged segments and rough patches of the selected region that requires immediate repairment are suggested. This information can be used to prioritize the repairment based on the available time and budget. The proposed solution is evaluated using more than 1,150 kilometers of trip records collected over 4 routes of Gujarat state of India. The proposed solution accurately infers the road roughness and identifies the damaged road segments for maintenance. Moreover, the ablation analysis of the proposal is carried out to evaluate the utility of combined execution of SOM and k-means algorithms. Further, the feasibility of proposal for a large-scale deployment is assessed. The analysis shows that the proposed system is scalable and can process the daily transit data of a metro city using the in-bus controllers and a server. The picture on the top left shows the block diagram of the proposed system, comprising of the bus module and the server module. The bus module is the device used to fetch, process, store and communicate the sensor data for the bus trips of different routes. The bus module can be implemented using the dedicated system comprising the Omega 3 to 8P microcontroller 1 interfaced with the GPS sensor and gyroscope and accelerometer sensor using the smartphone, comprising the GPS and motion sensors. In literature, the researchers have concluded that the smartphone can be used to infer road conditions. Hence, we decided to implement the bus module using an Android smartphone. The smartphones have high penetration and sophisticated application development platform, providing rapid deployment at large scale. Server module is the central component of the proposed system. It receives the trip records, comprising of GPS location records and vibration features of different routes, using the bulk data transfer from the bus modules. The server module computes the road surface roughness and the damaged road segment using these trip records. It comprises of several sub-modules. In the following, we describe the functionalities of these sub-modules. Database. It stores the trip records of different routes in the database. The road parameters are computed using the trip records. The computed road network parameters are stored in the database. Road categorization. It applies the combination of unsupervised learning-based SOM and k-means algorithms on the features of GPS and accelerometer records for road condition monitoring. The SOM algorithm identifies the damaged road segments and non-damaged road segments. Further, the k-means algorithm infers the roughness of non-damaged road segments. Digital map update. The proposed system updates the computed information about the road roughness and the damaged road segments on the digital map. Evaluation process. Present the evaluation of the proposed solution. First, window sensitivity analysis. The STD feature is calculated by extracting the accelerometer data overlapping window of samples. The appropriate value of W was the concern during the implementation stage. We studied the literature to determine the range of window size used in the existing works Ericsson, Ruillard, and analyzed the effect of window size on the STD value. Secondly, data analysis using SOM and k-means. The figure shows the distance matrix D and head count matrix H for the internal road stretches and the highway stretches. The distance matrix plots also contain the markers of different shapes at each location of the rectangular grid of neurons. The neurons with Y marker corresponds to the damaged road segments road, obtained by comparison of the distance of neurons. Third, road condition inference. The road roughness inference and damaged road segment identification are obtained for the test routes. Fourth, ablation analysis. This subsection presents the ablation analysis of the proposed solution, wherein only one of the SOM algorithm and the k-means algorithm is, and the inference quality of damaged and rougher road segments is evaluated. Fifth, effect of number of bus trips on coverage of monitored road segments. In this subsection, the effect of the number of bus trips on the coverage of monitored road segments is assessed using realistic simulations. Sixth, scalability assessment. This section analyzes the memory, communication and computation requirements of the proposed system to assess the feasibility of its large-scale deployment. This paper presented the unsupervised learning-based solution for road condition monitoring. The proposed solution uses the public transportation buses as mobile sensor and utilizes their dense trajectories for road roughness computation and identifying the damaged road segments. The proposed solution can be used to provide the dynamic suggestions for the repairment of damaged road segments and rougher road segments based on the available time and budget. The proposed solution is evaluated using the trip data of more than 1,150 kilometers collected over the 4 routes of Gujarat state of India. The local computation of vibration feature in the bus module significantly reduces the memory and communication requirements. The assessment of storage, communication and computation requirement of the proposed system shows the feasibility of processing the road network data collected by a transit system covering the whole city or a larger region. In future work, we aim to process the collected bus trajectory data to compute the other road network parameters, such as the location of junctions, their categorization, and control.